Our next speaker is Paul Cruz.
Hi, good afternoon. I'm going to present on my own, but Murali Ramachandran is here. He's our CEO of ATOS India. It's a great pleasure to talk to you this afternoon about the power of analytics, not just from the renewable integration point of view, but from also the how can we improve the grid operations and maintenance. So we've been talking, of course, about how the energy and utilities is being transformed thanks to the digital transformation. But I'm just going to give you here some figures, just for you to get an idea of what's going on. 50% of the staff of the industry is going to change over the next 5 years. So that means half of the people that are in this room will not be here in the next 5 years. $80 billion are being saved thanks to the digital transformation. There is about $2 billion that are spent around asset management and smart grid. And 20% of the utility market is going to be seized by digital disturbers, that people that are coming to eat our lunch and dinner. So by 2021, in 3 years' time, so the world is changing, and it's changing very fast. So we talked about, from our colleagues from PwC, what is the things that are motivating these changes. One of the things I'd like just to talk about is the prosumer. We've been talking about the emphasis on the consumer point of view, but the consumer is becoming also a producer as well. So that's something that indeed is changing, and we call it the smart X, the smart cities, the smart homes, the smart factories, which hopefully is improving the whole industry. And of course, the digital is enabling all this thanks to, we heard industrial IoT platforms, we heard also the real-time enablement. Artificial intelligence is going to be, of course, a very, very big also enabler. So I'm going to give you, hopefully, some clear examples of what we have achieved in the industry. But why is this happening? Why is this happening now? Why are we talking about digital transformation? I mean, I started my career personally 30 years ago, and I was doing digital then. I'm sure Richard, a bit older than me, was doing digital then. But why are we now talking about the digital transformation? And why is it accelerating at a pace unprecedented? Well, simply because of this graph here. The graph is saying simply that since 2008, 10 years back, storage, data collection, telecommunication bandwidth have decreased by 90%. So it's a simple economical factor. These technologies that you see here from Apple Watch, I don't know if you know, but Apple Watch sales was more than the whole Swiss watch industry last year. So just to give you some facts at the pace of the disturbers that are here, we talk about robots, but all this is coming at a pace unprecedented because of these figures that are down here. Now, ATOS, just to give you a bit of advertising about ATOS, because it's important just for you to put the things in perspective. We are an IT organization, 120,000 employees, and Murali is our CEO here in India with about 36,000 employees. So we have 30% of our workforce, which is not French, actually. It's actually Indian. So we are a big Indian organization here. We do about 13 billion revenue. And one of the flagship of our projects is the Olympic Games. We are the IT supplier of the Olympic Games. So that's our flagship project. And one of the things we build as well is big supercomputers. And one of them was sold recently to the Indian university industry. And I believe a couple of weeks ago, he was inaugurated by the Indian Prime Minister, this new supercomputer that was installed here in India. Just to give you some ideas as well about the fact that, and I'm sorry, the diagram didn't come up here very well, but we see as well a lot of changes in the ecosystem thanks to this transformation. The business models are changing, of course, because of this integration of renewables and so on and so forth. And this has an effect on how to optimize as well locally more the infrastructure. And the involvement of the cities is becoming more and more. One of the things as well that you don't see here very much, but we talked about it this morning, is the convergence of electricity, of gas, and also water. The convergence of how this interdependence and how can you get some optimization out of those things. We also can add to this convergence the electricity mobility and the mobility in general. So just to give you as well some ideas of projects around smart grid operations where we have been involved in demand response projects, but also renewable integrations projects. Also the traditional SCADA, EMS and DMS, and just to let you know, we are currently we are currently implementing the modernization of the French National Grid Control Center of the RTE. This is something that is going on at the moment and trying to bring a bit more modernization to it. And also other DSOs and TSOs you see down the line here from the UK, from also Spain, Switzerland, and Italy here. Okay, so all this comes from a complex set of offerings that needs to be addressed from control systems, but also from more smart grid-based solutions. Now, we talked about some big data analytics idea. Now I'd like to concentrate on giving you some examples of what can we do with this data once it is acquired, either from, we hear, smart metering systems, but also it can be normal metering systems, but also from the historical data coming from the SCADA systems, from weather data, and what happened when you can put all this together and when you start developing correlations that you didn't think about. So here, one of the things that we've done here is to increase the forecast of renewable generation. The idea is to bring all this data all together. We know, unfortunately, that the weather forecast is not accurate enough to give us the real-time vision. And how can we, through this integration of weather data, but also historical data, and maybe using a swarm computing, neighboring systems adjacent to a point, how can we increase this data? So we've done a project together with NADs to increase the integration in rural areas of this intermittent solar photovoltaic at a micro level. So this is one of the examples, and the idea as well is to reduce the cost of balancing the network, because this lack of inaccuracy makes the DSO having to buy in real time, in spot markets, the energy. And of course, this is a very expensive way of balancing the network. So if you bring a bit of anticipation on the imbalances, then you can forecast the procurement of this energy and thus reduce a bit the invoice for buying this electricity. So this is this example I'm talking here about. How can we enhance at the local level the balancing of the network? Also, one thing you can do with all this data that you are gathering is to predict failures of your equipment, your transformers, your substations, your switch gears, etc., etc. So here you have things that we didn't anticipate initially is how can we correlate as well, for example, weather conditions. How can we take into consideration, for example, humidities, for example, temperature, ambient temperature, in maybe forecasting some failures, and adding to the routes and the rounds of changes of all this. So here again, this is one of the examples of what we did. By the way, this predictive maintenance, we call it, it's not new, we call it big data analytics. I've got to admit that EDF and ourselves have been working since nearly 30 years. I was a young engineer then on doing exactly that for French nuclear power plants. The project was called PESAD or SAMT. So we were doing already, not in big data analytics, but in Oracle databases with artificial intelligence already then. We were trying to predict cavity of primary pumps or de-alignment of, thanks to vibration analysis of the turbines. So all to say that these are a lot of legacies. And again here, trying to use all these systems to gather all these data together and to try to predict all this. We hear as well non-technical losses earlier on, and non-technical losses account for a lot of the business case for rollout of smart meters. But once you have all this into your system, you put that into the data lake, and then you need to do some analytics to predict the potential instances of non-technical losses. So here, this is the technology we use to detect those losses. Again, this has been deployed a lot in Spain, and we're working in France with other utilities to develop that. Not EDF, the other big one. NG. Here, this is something we've done here in India with a solar and wind farm generator. And the idea is to centrally monitor all their wind farms coming from different manufacturers and centrally have a view at the national level of what's going on in real time, and again to help predict failures of their equipment, knowing that the inevitabilities of wind farms are quite big, and also adding the digital twin concept, improving the accuracy of data, as we mentioned earlier on, engineering data, but operational data, to try to get this better availability overall. So I think this is the last case study I wanted to share with you. This is as I mentioned before, how can we lower and optimize the cost of balancing the network thanks to adding this thing. So in conclusion, the electricity system is continuing seeing major disruptions, we know that, and because of environmental pressure, we're going to generate power differently. We have geopolitical evolutions, which makes maybe the mix of capacity changing. We have major changes in business models. We talked about the convergence of players earlier on. We see as well the fact that the energy and utility sector is by far one of the slowest to adopt technology, and we know that other industries, manufacturing, aerospace, etc., go at a much faster pace. So how can we accelerate that is a big challenge, and the convergence of all these different industries. So it's essential to anticipate and respond to these impacts, to bring positive effect and reduce potential threats. Otherwise, newcomers will come and eat our lunch and dinner, and our client can rely on us to help them to go through this digital transformation. Thank you so much.
Thank you so much, Paul. Really appreciate it. I was intrigued by some of your slides here. I just have a quick question, and we'll take a couple more questions. You talked about non-technical losses, right? And this is the amazing thing, digitization. We talked about the benefits of why digitization, right? Exposing the non-technical loss doesn't solve the problem, right?
Yeah, that's right.
So what was your role? Were you helping the utility expose the non-technical losses? Or were you helping the utility solve and find methods to recover and solve the problem?
The identification of so we know there are non-technical losses. The idea is how can we identify where, and how can we, because you need to send a team to actually detect this thing. And the idea is here to detect accurately at rates that are higher than 60 to 80%. When you send a team, you've got a guarantee that you're going to find an exact non-technical losses, if you like. And then you need to negotiate, of course, with...
How to fix the problem.
But here what we do is just to detect the loss and send the team to actually do the job. By the way, particularly in France, the non-technical losses is not just the will to actually fraud, but sometimes you have the wrong contract with a wrong capacity contract. So here it's to actually improve the actual contract that you have at the right level as well. Because your smart meter will not allow to go over the subscribed capacity.
You mean the wrong tariff?
Exactly.
Okay, gotcha.
Yeah.
Okay, thank you. Thank you so much. Any other questions? Please.
So in this, it is digitizing the grid. So if you implement any mathematical engine to that computer, like Kalman filter or the particle swarm optimizer, how it can be interfaced in this computer? If any new emerging mathematical engine comes that can solve the problem with the help of this computer, how you can deal that thing?
So if I understand the question is, how do you model, or how can you make cohabitation of different models of the electrical system? Is that it? No?
Like many mathematical engines are there,
yeah.
Like Kalman filter is there, particle swarm optimization is there.
Yeah.
They are also doing the same thing. But if you want to implement another new engine that is improvised version of Kalman filter or the particle swarm optimization, how the existing this computing the smart grid will take that benefit of this mathematical engine in this system.
Sorry, I don't understand the... Okay. Okay. So,
and Paul, just so you know, if you feel there is a longer answer, if you want to take it offline, you have the
possibility
to do so.
I'll take that option. Is that okay with all of you? Maybe we take it offline afterwards.
Connect with him offline,
but,
okay?
yeah.
No offense intended.
No.
Because it's a good question.
Yeah,
Every question is a good question, but take some more time to explain and go through.
But also there are one thing that is happening a lot in the industry as well is the machine learning. Okay, so machine learning is really disturbing the way existing models work. And today you can maybe get better results at putting all these old models aside and starting from scratch with maybe machine learning, which will give you a more maybe pragmatic models as well. Okay. So I'll talk to you how you make maybe cohabitations of all these different models later. Yeah.
Yes. Thank you so much, Paul. Really appreciate it.